Hi, everybody. I'm Giuseppe Amatulli. I'm working for the Yale Center for Research Computing at Yale University. I'm part also of the School of Forestry and Environmental Science. Today, I'm going to talk about GRASS GIS. That is a geographic resource analysis support system for geographical operation, geographic and also remote sensing operation. I'm going to go through this presentation that you can find directly in the spatial ecology website. If you just Google spatialecology.net/docu-wiki, so you can see the URL over here. You can scrolling down, and I'm going to address in the third point, the third web seminar of this week-long presentation. So you can find over here the presentation that I'm talking about. Then I will go through the material, and we will have hands-on practice. And then we will go also in the material 2, that is a bit more advanced practice, in order to be able to start the GRASS directly from the command line. Christine is also pasting in the chat the material, the 3 links. So feel free to just click and follow the presentation. Anyway, the presentation will be there. Also, the recording will be available through the YouTube link. So you can also referring to this point, to this web page for finding all the links. I'm going to talk about the GRASS feature. The GRASS feature, the structure of the software. So far, we have talking about GDAL and PK tools, and we talk exclusively about the syntax of the command. Here, there is another step to do before to enter into the GRASS. We need to understand very well about the GRASS architecture. And this is very important because it's not a easy software. Let's say it's not a software that can be, you can do a easy and fast dragging of file or copy paste of file. You really need to understand the architecture of the software in order to be able to compute later on any kind of analysis. So today we will focus mainly on this, on GRASS architecture and feature, and we will see the command structure, that is the typical bash syntax. We will not do it so much GIS operation, because that one is something that you can do it later on when you understand very well the GRASS architecture. So we will present a very simple command line, but mainly for dealing and understanding the back part of GRASS architecture that sometimes is not very easy to get it, especially in the first beginning. We will working with a GUI, with graphical user interface, but mainly also with terminal. The GUI has been developed very well in the last 4-5 years with a Python graphical user interface. So it's very handy and is very useful. I will show you how to learn the command line through the graphical user interface. GRASS is part of this open source concept where it's very, from a scientific point of view, is very good to have the code open. In this way, you can really understand which kind of analysis is done in that code, and also for in this way you achieve transparency. So also you achieve reproducibility, because you can reproduce the data, and you can also identify different way how to improve the scripting procedure, or how to change it in according to your needs. Several times I found a code that is very similar, is doing almost what I want, and I was able to enter into the source code, changing few lines, even if you are not a perfect programmer that can rewrite the full code, but you can try and changing few lines and then recompile it and do the analysis as you're expecting that the output that you were expecting. GRASS has been a long story. It has been developed from the 84. Then it was completely abandoned for a long period, when a bunch of developers in 2000 get back the code and start to developing even further until arriving today really powerful GIS software that can run, and this is extremely important, that it can run in a laptop, but also in supercomputer. Okay, so whenever you you work in your laptop with a command line, then you will see that is not, if you understanding very well the command line of GRASS in your laptop, then it's not so difficult to jump over in the high performance computing. That is something that we will cover tomorrow. So it's a free software, and this is part also of the OSGeo Foundation. And in particular, the OSGeo Foundation is the OSGeo Foundation is a foundation that is including all the initiative concerning the open source. So not only GRASS, also the one that I mentioned yesterday, GDA, Pika Tools, QGIS. So it's very open community with a lot of activity. So I really suggest you to subscribe for the newsletter. And the GRASS Foundation is also part of Geo4All. Geo4All, you can Google it fast, is part of the OSGeo, is an initiative to disseminate the use of open source in the context of geographical analysis and remote and sensing analysis. So we are running event. There are different labs. We are also part of the lab as a Yale University, as a part of Yale University, but you can see that are spread around the world. So try to refer to this lab of your country in order to get help, to follow initiative, and so on. Something very important is that GRASS is not let's say a standalone software that is not lonely in the planet, in the sense that it is really linked and is supported with, integrated with GDAL, PostGIS, Quantum GIS, Map Server, OpenLay, R. So like I mentioned yesterday, this integration of language in they're working very well when you work under a Linux environment. So you can really let GRASS communicate with R all the way around, or GDAL communicate with GRASS, and all this kind of system. They can be also linked with, for example, with Map Server or Open Layers for web GIS interface and analysis. So that's why it's not completely lonely in the term of potentially in linking with other software. It's very portable. They can be run in Windows, Linux, and Mac. So also for Mac user, you can find, just put GRASS GIS Mac user, and you can find the installer for the GRASS software. And he does 350, even more modules for management, processing, and analysis, visualize raster, image, vector. And when I say raster, just the typical matrix, or image in terms of image from satellite, even vector for GIS analysis, like shapefile or JSON or SQLite, and so on. This is quite appealing in the sense that be linked directly with GDAL. All the format that you can read can be also read by GRASS. So you can really manipulate any kind of format without big issues. It's very well linked with the QGIS, and QGIS is also useful for visualize GRASS data. And also to make there is a plugin of GRASS. There is a plugin for QGIS of GRASS that is allow you to perform and visualize both analysis done directly in GRASS and inside to QGIS. I prefer to do working directly and only with the GRASS command, and with the GRASS command using a graphical user interface for visualization, or even better, due to that I'm working mainly in the high performance computing. When I finish my GRASS analysis, I pull it out the TIFF, I exported the TIFF, and we will see how. I exported the TIFF, and then I open this TIFF with the software OpenAV that I was mentioned to you guys yesterday. So this is more or less my flow chart that I use it. But feel free also to use QGIS and GRASS together, or even for people that are working mainly with query and database and vector, more in the vector environment, is also very well linked to PostGIS. And of course, is also linked with R. And especially this is quite important in the moment that you do all the geographical analysis or geographical analysis under GRASS, then you can get your final result of your final table that you want to do the statistical modeling. In this case, you do it inside to R. Inside to R. So, but let's see, let's go deep in the, enter slowly into the architecture of the software. The beauty of GRASS, and I would say of mainly all the open source software, is really this part of it here, that user and developer are completely inside to the same environment, okay? Some of the users, they become so good that they become they become passionate, they are passionate about the software environment, and they become developers, and they can keep communicating through the internet with backtracking, tracker and with the mailing list. The mailing lists are really a really good source of information and helps for particular situation, for any situation that you want, from a beginning question or even a more complex question because you find some doubt or you want to questioning something that you didn't find. There are also very good documentation and sample data for testing. And we will see which one to use and how to implementing very simple scripting procedure with this sample data through the explanation. So this communication between user and developers is coming through the mailing list. 2 days ago, I was asking to the GRASS mailing list some question concerning my hydrological modeling. That you do is very complex. So I was trying to see how I can achieve and how I can overpassing some particular drawbacks that I can find out. So this is quite chilling and nice because you can have really a feedback from the developer, from the guy that wrote the code, or from his colleague that later on take over the code. So this is really, you can really achieve something very strong and update the most level part of the science. GRASS can do different kind of analysis in the 2D and also in the 3D vector, so in the cubing system, in volume and surface. I didn't use so much this aspect, but it's something that is really appealing. Then you can do a lot of image processing for remote sensing analysis. And also this one are really upfront, even with the new technology and new satellite data. And so there are models for ingesting, of course, the old but still going on Landsat mission and MODIS mission, but even the more recently one, right, Sentinel, other new satellite, or even working with the drone mapping and integrating the drone mapping with the different kind of other open source software. They can also working with vector data. And for vector data, I consider not only the typical vector shapefile, but also the input in LiDAR. Yesterday somebody was asking me how I can perform a LiDAR ride operation in the open source. Well, so the GRASS can do it, a lot of these operation under LiDAR. So they can ingest the LADS files, LiDAR file system, so file format. So it's very efficient to work in this direction. It can operate, I would say, under Linux Max, but you really have the maximum capability under Linux. We will see how and why. And one of the most important part is not only the graphical user interface that we'll see a bit, but the scripting capability that allow you to the batch processing and the massive processing, especially in the high performance computing. But as I mentioned before, the architecture is something extremely important to understand before to jumping inside to GRASS. So let's see together, when I talk about GRASS architecture, what I mean, what I mean. So is a software that has been developed from the '84. So his main was driving the architecture of mainly two aspects that they were driving the architecture of the software. One was the presence of users, that different users that were using and sharing one computer, and second, the low amount of RAM. Okay, all these two together, they really drive the how I can perform, how I can do it, GIS analysis, having in mind that I need to have a software that is able to deal with the really low amount of RAM, and also that allow different users to log in into the same system, into the same architecture, and also in sharing and using their own data. Okay, so in this context, they build up an architecture that is very rigid, fixed. Why? Because they have to allow the different users to work in their own environment, but they have also to allow to the data stay, the input data stay there and preserve their nature and the original situation. Okay, so for example, in our case, we are going to use an architecture that has been built, and in this case, each single polygon is a directory. So try to think that each single polygon with this shape is a directory. So in my case, we will see in the virtual machine, we have always a GRASS database. Okay, that is a folder. Okay, with inside, and this is called GRASS database. And most of the time, the GRASS DBase. So most of the time, they always, even you will see in forum and in example, they always suggest to label in this way. Anyway, it's a name of a folder, so you can call as you want. But it's important to have in mind that this one is the GRASS database. Inside the GRASS database, you have the so-called location. Be careful about this. These are the 3 steps that you have always to keep in your mind. The GRASS database, the location, and the map set. The location, in my case, usually is referring, and you also giving the same name, a name that is given to the location where you are working. So if you are working in the context of Europe, you can call Europe. If you are working in Africa or in Kenya, you can give the name of the country and so on. But something that give you a reminder that one is the location. Okay. Then, so try to always give a name that is helping you to create this architectural link. Then you have the map set. Okay, so this is also in the map set. There is always as a default and immediately automatically create from the software a folder that is called permanent. Okay, and this inside the map set, there are also other folders that, let's say, you can give the name of your project. Okay, and I will give you a few examples of how you can helping you to differentiate each single project. For example, if you are working in the context with digital elevation model, your digital elevation model that is going to be your input data for the different project, you're going to have it inside permanent. Rather, in the moment that you are doing a project in the context of, for example, erosion, you will call this one erosion. So you are going to having your input data, the digital elevation model in permanent, and everything that you are going to produce for your erosion model, so erosion quantity, soil sedimentation, and so on, you are going to be saved in the map set that is called erosion. Rather, then you do an hydrological modeling. So again, you're going to have in the map set the input data, and everything about the hydrological model is going to be inside to this hydrological model. In my case, I was working, for example, with the species distribution. So my input data of climate data, they were inside permanent, and I was V model vegetation modeling, and PSM was for the percentage of the vegetation of the plant that I was investigating. Okay, so Anyway, these are the 3 steps that you always keep in mind. Really consider it as a single step, that every time that you enter in GRASS, you have to labeling, you have to say the software where you want to enter, and you have to give the full path: GRASS database, location, and map set. Okay, and each one of these is nothing else than the directory or where they are the 3 elements. Okay, so the GRASS set, in my case, the GRASS database is directly under OST for SAM. Then I have my Europe, and inside my Europe, I have my permanent. So I will give, for example, I will give the software the full path 1, and then to Europe, and then permanent. What does it mean? That as soon as I enter in this path, I will be able to see the data and manipulate the data inside permanent. Or I can even do it the same, GRASS database, Europe, vModel. Okay, so these allow you to working in a really efficient way, say, if you understand this architecture. Something very important is that, as I mentioned before, this software was built for using by different users and to protect the input data. Okay, so in particular, what I mean with this one, you can read the data from everywhere. So you can read the data from permanent or from vModel, PSM, but you can only write data that are, you can only write inside where you are located. Okay, so if you enter in vModel, you can produce data, you can read data from everywhere. Okay, but you can produce only, the output will be produced only in vModel. Okay, so this is very important because you can think that each single user can enter in one of these and can produce his own data. Usually now there is only one user, yourself, to work, but in order to protect your data even from your own mistake, it's always very good that you have your input data in permanent and everything that is coming out is under vModel. This one, there was a question, which one are the map set that we're creating as a first? Every time that you start from a scratch, the software architecture is creating directly a permanent, okay? Then you can create your own map set, and we will see how to do it. But the permanent is the default one. And each one of these is really the each one of these is the one that you are creating every time. And when you are inside, then you can save only save and write only inside where you are. And we will see in practice what I mean. And with a bit more example, it will be easier to understand. Anyway, always keep in mind, and if you are making some mistakes, most of the time is due because you are missing one of these 3 steps, or you are not very well labeled, or you are trying to do something, you are in a map set and you are trying to write in another one. So these kind of mistakes are really common before, until you, whenever you get to the tricks, then you can go further with any kind of GIS analysis. If you want to do buffering, or if you want to do hydrological model, but it's something extremely important that is a bit the black door of GRASS is understanding this. And most of the time, beginners stop immediately when they start GRASS at this point. But let's see in particular what they are, this folder, and which kind of information they are storing. So the GRASS database is as we mentioned, is a directory that store all the environment of GIS, all the environment of GRASS. Okay, and we say that inside a GIS database there are different locations. Okay, the location define the coordinate system and the map projection and the geographical boundaries. So what does it mean? That each location has its own projection. And something extremely important, with GRASS, you cannot mix projection, okay? Rather, in other software, in ArcGIS or even in QGIS, if you open two layers that have different projection, they do on the fly reprojection. And sometimes you don't even realize that there are different projections because it's done and you see the overlapping. GRASS no is extremely rigid. So that's why the location is helping you also to link with the map projection and geographical boundaries. So location, for example, I'm going to use in Europe, I'm going to working with the LAEA for the European system. Or if you're working for the United States, I'm going to use the NAD 27, that is the projection parameter for United States. If I'm working at the global level, I can use the WGS 84 for the global implementation, okay? So this is extremely important to get in your mind, that the location has to be built with a data set that has a particular projection, and then each single data set that you are going to ingest, import in that location has to have the same projection, okay? So this is something extremely important to keep in your mind. Then the third point that we saw before, we have the map set, okay? And the map set is organized in team, like I say, like your model, okay? Inside the map set, there are all the data set that you can store it. We say that there is always the permanent, okay, plus the other. So whenever you start, you will see always a permanent plus some other that can be there or cannot be there. And inside the map set, where we are going to you physically work inside the map set. Okay, so let's go through the complex. Let's go through the complex architecture of the file system. In this particular aspect, we need to understand that due to this three-step very well defined, you have to have a data set that have projection information. So how you check if they have projection information? With GDAL info. Okay, so with the GDAL info and with the GDAL edit, you can see and edit the projection parameters, okay? So usually, most often, whenever you download data set from internet, especially if they are really huge data, I mean, not huge data, but very well-known data, MODIS, Landsat, or country border or shapefile, this one, they always have projection information, okay? So you can have a problem with some projection information with you download data from a small authority, or you are crossing over different country with different projections. So in that case, you have to be very careful, and you have to have your data set really well compiled to the projection, and be sure that have the same system. So if you have projection different with WGS 84, but your data set belong to a single country, like in UTM 45 North, then you have to be able to transfer your UTM to a lat-long system, or your fuse UTM 45 to UTM 46 North, okay? And this one, do it before, and do it with the GDAL warp or with the GDAL edit and GDAL info. Don't do it in GRASS, because first you will get a lot of error, and then it's quite difficult to do it. So I always prefer entering GRASS with all my data set already set it up with the same projection. Okay, so let's see in details the architecture of GRASS. Okay, so like before I mentioned, we have our three parts. Okay, so we have the folder, the GRASS database folder, the map set. Okay, and let's see what is happening inside each one of these. Okay, inside the GRASS database, we can have the different location. So for example, I work with world, Asia, Spain, Europe. In our case, in the virtual machine for a matter of space, you can see only Europe, okay? But try to imagine that there can be others. Inside the map set, you have the permanent, okay? And inside the maps, as I mentioned, inside the permanent, you can have different model, okay? So let's see what is happening under the map set. There is as you can see, there is a very complex structure. Okay, you don't really need to. You need to know that is there, but you don't have to touch it. Okay, so it's something that the computer is going to deal with. Okay, the software is going to deal with. Okay, so something that for you is very important is all this part of it here on the left side. And this part of it here on the right side is something that the software is going to take care of you. But it's important to know where they are storing the information and what you can go and check and see if something doesn't go through very well, okay? Very well. So let's see, for example, inside permanent, we have one section that is for the vector files, another section that is for the raster file. Then we have also another section for the V model, in case you are working with a 3D map, okay? For the 3D map. So, and then you will have another section that is for the database, where the attribute of the vector map are linked with the database, okay? In each single raster map, you have different folder. And this is why GRASS is particular. Your file, when we were working with a TIFF file, your file was only one, okay? GRASS know every time that you import TIFF inside GRASS, the file is going to be split in different location. In this different folder, and these folder are the cell H, and so on. So, for example, in cell there is the matrix. There are the information about the value of the pixel. The header, there are information about the boundary and the statistic of the file. Inside this one, there are the color. If it's a floating point, the value of the cell are storing inside here. Over here, they're storing the histogram. So as you can see, the file is splitted inside to this folder. So again, this is the part that you don't have to touch it. The software will take care of about it. So it's very important to but it's very important to understand what is inside MapSet. And we will see in practice. Some people are asking me how we can enter. We can see in practice how to use this location MapSet, so name of the folder, to enter in the right position, okay? So this is explaining details of what I will just mention by pointing to the graphic, so you can go through and check particular one by one. I was talking about the raster vector, but it's pretty the same for the vector maps, okay? So the same, they are storing the information about the color, the histogram, the topology of the vector map. So it's really pretty the same. Let's see a bit now that I explained the architecture, and we will try to understand even better the architecture when we do the simple example. The simple example. So we will see how the GRASS command is built. Okay, they are very easy to recognize because they always start with one letter or maybe with two plus dot. Okay, so the G dot stay for, they are the general management. They are the file that they are useful for renaming a map, setting the map set, changing map set. All these ones that are generic, are not referring to a particular format of the data, are the one that you can use it without, that are labeling with general management. That's why it's type for G. Then we have the D, the display. This one was quite important in the past when you were doing maps by display. Nowadays, with the graphical user interface, we don't use so much command, so you can even ignore for now. Then there is the R, is for raster processing, is the one that you will use it mainly for, for massive data process in the raster environment, and are all the one that is started for buffering profile. So our MapCalc, our Univar, our buffering, our watershed for hydrological modeling, our sun for sun exposition. So there are plenty of them. You can have a full list of commands and also documentation. The V is the one also extremely important for vector data. So for cleaning, topology, building up topology, buffering. So then you have the one for database management, for linking and manage the attributes that are linked to the vector, okay? So, and also in case you're working with the connection between PostGIS and GRASS, is the one that's going to be extremely vital and try to link it everything. I'm mainly working in the Rust environment for massive data process, so I don't do so much with the vector. And for me, the vector, as I mentioned before, as soon as I get a vector, I transfer to raster to be able to combine mainly with the other raster data. So this is something that we need to, you need to working through to understand all the combination that you can do it with this powerful command. There is also another sector. These are the command, the generic command. We'll see that GRASS have also add-on. There are additional package, additional command that you can. They are not belong to the main distribution, but you can every time import it, and we will see the web page where they are stored and so on. Let's see the syntax. Let's see the syntax of GRASS. GRASS, as the typical, as I mentioned before, was built in the 84 under Unix Linux system. So the key synopsis, the syntax of the command is like the one that we saw before, we saw yesterday for GDAL and PK2. So you have the command between square brackets, flags or option. They are called it flags or option, so that you can select a parameter that has to be there, so it's without any square brackets, and then some other flags for overwriting, for be quiet during the computation. So all these parameters you can see. So let's see in particular what how a single command is built. So for example, if we want to do the buffer around a stream network or a road, you can have the command rbuffer. You will have your input, that in this case is going to be road. Your output is going to be your road buffer. I'm going to select the distance of each single buffer, 100, 200, 300, and so on, and my unit is going to be in kilometers. So all these levels are nothing else that every 100, 200, 300, and 400 kilometers. And this is the flag override, okay, that you are going to inserting every time that you want to override. So in this case, the default for GRASS is not override. The default is not override. So every time that you want to override, you have to insert this option that quite often is also abbreviated by -o, --o. So this allows you to, without any problem, to override the data that you are building. Okay. So this line is the line that is the command line that is helping you later on to build up a scripting procedure in this way, okay? These are the two graphical user interface that you use. You can have the Vuix, the Python Vuix, the new one, okay? That has been developed like 8 years ago, more or less. And this one is the QGIS graphical user interface that you can link with GRASS. Most of the time I use this one, but again, I use it only for some fast testing, just to checking the data before to do the full computation. Because if I do the full computation in the cluster, I cannot open any graphical interface and do the analysis. So I do the analysis by scripting procedure. I pull out my TIFF or my 200 TIFF that I create, and then I open all the TIFF with OpenEV, okay? So this is how I build up my scripting procedure for the analysis, okay? Something extremely important is also the, and we will focus mainly in this one, we will touch in just a bit the graphical user interface, also because that one is something that you can deal it by yourself. You can try and testing with the graphical user interface and clicking everywhere. So rather with the command line, we need to be more carefully. So we will work a bit more focusing on that in that direction. Perfect. So the graphical user interface, we will see that, as I mentioned before, is going to be directly nested inside the bash Linux command, the bash language. So we are going to interact with both bash and GRASS. So that's why it's extremely powerful to to use it also in these terms. GRASS, there are also binding for using inside Python, but I still prefer to use it directly under bash, because inside Python you have to use a lot of quotation, and because you are combining the Python language with the bash syntax, so you have to know both. So in the end, I just say for myself, I just say, okay, I will just continue the bash. I need to do dealing with two kind of syntax error. One is going to be the bash, and one is going to be the Python syntax error. So then you have to be troubleshooting the two syntax error. So rather, if you work directly in bash, you know that the syntax error at least is coming only from a bash problem, let's say. So let's see how we can work in this context. As I mentioned yesterday, something that you can use it by yourself, especially if you are beginning you want to learning working in the Linux environment. There is this platform, liveosgo.org, that is preparing a. Actually, we can go directly there. Just Google it, OSGeo Live, and you arrive to this web page. Okay, OSGeo Live, osgeo.org. So this is a web page. This is a platform. It's a Linux is a Ubuntu, so light Ubuntu, where all the software are already installed and precompiled inside to this platform, inside to this machine. You can download it and use it as. You can download and use it as a virtual machine, or you can use it for full installation. And the beauty of this is that all the software in the geographical analysis are already pre-installed there, already installed. You don't have to deal with. So it's something that you can really, and over here you can see, you can download from here, and you can follow the installation procedure for the full hard disk or for the virtual machine. I suggest, especially if you are a beginners, to working with a virtual machine. Build up a virtual machine with VirtualBox. From here, you can get from the download. You can get the file, and you can go directly from installing in your hard disk, in your Mac or your Windows. So this is the easy transition. This way, you can have your operating system that you know already, the Windows or the Mac already there, and you start slowly transition into the Linux machine. And then after 5-6 months that you feel confident, you can go for a full installation, okay? So this is something that you can, already do it. Okay, so we will see how to.
مشيت اتحدنا يلا والله
وماك ما مشيتش
مشيت معي اذا واحد ما مشيتش.
Some people are mute. Could you please unmute yourself? Thank you. In the OSGeo, there are two software that are all the software are there. There are two software that are missing, maybe more than one, but the one that I use it, they are missing: the OpenEV and PK tools. So this one that you can directly, if you go to the spatial ecology, you click over here in installation. There are different tips how to install it, OpenEV. In PK tools, you can install it directly with apt install PK tools. That is the line, typical line that you use it for installing software, okay? So as I mentioned, in the installation, I will try also, there are some information about OpenEV over here, OpenEV in this page somewhere. So I will try to post it, the last command that I use it, and I will post it very clear. The last command that I did for installing in the virtual machine that I built up a few days ago, last week. So they are quite, let's say, new, because I did 1 week ago. So they will be fine for at least another 6 months, 1 year. So I will try to do in these coming days. Concerning some people that they were asking me, is there any interaction between GRASS, GRASS and R? Yes, the two software are linked together. There are some library, SPGRASS, I think it's SPGRASS 6 or SPGRASS 7, that allow to bundling, yes, to importing GRASS files, GRASS raster or vector inside R. And we can see, well, I can point to you some example, but usually I don't do it in this sense, in the sense that I do my GRASS operation, I pull out the TIFF, and then I enter in R and I import my TIFF, okay? But there are some other possibility that you can read it directly, the GRASS data inside R. And we will see how to do it. I mean, we will see, I will point to you, because now we are focused more in understanding the structure of GRASS. Anyway, over here, all these combination between language, you can find example in language integration. So over here, there are plenty of these examples, how to combine GRASS and R, how to combine GDAL and Python and so on, all the different combination that you can that you can find. So let's go back to, yeah, so this was the last slide of my presentation. So now we start the hands-on. So I will, the hands-on, I will, as I mentioned before, I will use it. I will use the spatial ecology DokuWiki. So if you just go in the, third appointment of today, you can see the material 1. So material 1 is bringing to you, if you click, is bringing to you. So Christine, you can paste again, just in case the link of material 1. So you can arrive directly. You can arrive directly to this web page. Okay, the beginning of this web page is nothing else, is bringing to you pretty much what I was explaining so far in the presentation. So we can go directly inside to the graphical in the command line example. Okay, so every time that you start, there are few commands, so you can even type. I mean, or copy, even if you're copy paste, because sometimes Mac and it's not easy. The copy paste can create problem. We have few users, I think. Yeah, we have like 4 or 5 users inside to the virtual machine. And so feel free, the users that are in the virtual machine, feel free to copy paste and do pretty the same, which should work. Please, if you're open the graphical user interface, should pop up something like this one that, as you can see, is taking a bit of time, not only for starting GRASS. You can have some, these are not really error, are just warning. So it's bringing up these windows. So these require a bit of time to go from the server to my desktop, to my screen. So that's why it was a bit slowly, okay? So, so every time that I say close, especially people in the virtual machine, please close everything and be sure that your Windows is open. So whenever you start GRASS, GRASS is going to ask you where you want to start, okay? So in where you want to start means that that is going to ask these 3 steps, your GRASS database, your location and your map set. Okay, so you have to define. So can be some cases. So in these cases, it's already predefined. But if you start the GRASS in another directory, like this one, is going to warning you, okay, these are not my typical GRASS database location map set that I want. So this is why you have to give the full path, and the moment you give the full path, the correct one, he recognizes how to enter. So in particular, we are going to use something that already exists now, a database, a GRASS database that already exists to understand the structure, and then we will use, we will see how to build up the GRASS database completely from scratch. So from, in your case, when you want to start your project and so on. But before we are entering something that exists already. So whenever you say start a GRASS session, that you identify the three paths, in my case, it's going to be GRASS database, Europe, and permanent. Permanent, I can select permanent. So be careful when you select, sometimes it's a bit slowly, because again, it has to communicate with the virtual machine. So now you can say start GRASS session, okay? So it's starting the GRASS section. And this should be popping up also the the graphical user interface. Probably will take a while. So you can imagine, yeah, now it's coming. So that's why is another reason why you are working a server, you don't use the graphical interface, because it's also requiring time to bring the information from the server to your computer, okay? So usually always, if I use the graphical user interface, I organize my screen this way. I have over here my command line that I can use it bash command, because they are integrating, as we mentioned. So I can make listing and see what I have. I can change directory in a particular directory and so on. Over here you have the display. Over here you have all the command that you want to, the platform, the menu for running a command or open a file. So in this case, for example, I can open a file. Look, also here is taking time a bit to open, and you can select. So if you click over here, you can select the raster. So you can, is opening the raster. Let's see if it's opening. And then if you select one particular file, then you have the display over here on your right side, okay? Probably now there are 4 or 5 people that are trying to do the same, so it's becoming a bit slowly. Yeah, okay, now we get it. So as you can see, it's taking a bit a while to, and then if you do apply, okay, you can see that now on the right, there is the rendering, and is appearing over there, okay? Then you can do okay, and you can do it. Actually, let's do it okay in this way. I can close the window. Over here, inside to the raster, inside to each one of these menu, for example, there are all the commands for the raster environment. So all the ones that were started with r dot something, okay? Let's pick up, for example, one. There are one that are directly, and there are one that are more, they have many commands under the same R clamping, for example. So every time that you click over here in one of these command is opening a dialog. So, and every time that you pay attention to this in particular, every time that you read the manual, you can go directly to the manual. You can browsing even R clamp inside GRASS R clamp inside your internet browser, and you can get perfectly the same. It's going to be the same manual that you find over here, okay? But something is extremely useful. So over here you can see all the explanation and why each single flag you can use it. But something extremely useful is the optional. Is every time that you select a parameter that is important, that you think that is going to be good for your analysis. Okay, so you build up also name of the output, you write over here out1 and so on. Okay, so over here is building up, as you can see, this one is going to be your command line. Okay, so this is extremely useful because you can copy this command line by say copy, and this command line you can paste in your scripting procedure. So that's why you say copy to the clipboard. So now you go to your scripting procedure, you do right click, paste. So that's why it's extremely important to use it. That's why it's quite important to use it, the command, this one, to learn it how to build up your command line. If you do it this one for 1 week, then you don't need neither to open anymore the graphical user interface. You understand the syntax, you check the manual, and you write your command directly in the command line. Leandro was asking me if there is a difference between the QGIS GRASS built-in and this one. No, they are pretty the same. They will do the same functionality. So if you are using QGIS and you are using GRASS through QGIS, yes, perfect is fine, but try to strengthen your skills in going the direction of building up scripting procedure, because that one allow you to really building up your scripting procedure, let the computer working, and you enjoy the night without stay there and clicking and doing the operation that the computer can do by itself. So this is really appealing in the context of batch processing that you are to try to achieve during the learning phase. Okay, so be careful and check it out carefully, this one, and every time try to build and copy paste and read the manual. Again, over here you have the manual and see how you can check. So let me close all this dialogue, and we enter again in GRASS. So please, all the people in the virtual machine, close all dialogue, close. Okay, this is force quit. Okay, I will force quit. And also be sure that you close all the window of GRASS. If you still see GRASS command, GRASS labeling, you can go from there, you can do exit. Let me zoom in a bit, this one. Zoom in. This way is bigger for you guys. Okay. So, so be careful. If you still see GRASS, this is the way to exit. You just write exit. Don't write exit directly over here. If not, you will pull out from the virtual machine. So now let's see. Now we select the three paths. So GRASS database, location, and map set with the graphical user interface. There is a way also to enter directly in GRASS with the command line. And now you are going to give the three element GRASS database, location, map set, and you will enter directly in that. So you copy paste over here, you can get directly inside to the GRASS GIS, okay? So over here, you can see that give you the welcome message. You can see that you can browse in, you can starting the graphical user interface with this command. I'm not going to do it, if not, it's going slowly again. But over here, you can enter, you are inside GRASS. Okay, so now pay extremely attention to this concept. Whenever you are in GRASS, you have two information in front of you. You have your location written over here, that you are inside GRASS in this location, okay? And you have another information that is over there, that is your bash directory, okay? So this bash directory, you can change it due to that you are inside bash, you are inside GRASS, but you are also having all the functionality of bash language. In other words, GRASS is not a completely new environment that you are entering, but it's like you are inside bash, you open the door of GRASS and you leave it open, okay? So your communication with GRASS bash, they are together. You can get in and out from the same room, from one room to the other one. Rather, if you enter complete in R or in Python, your door is completely closed. So you have to communicate every time with the operating system to do something. Rather, over here, between grass and bash, the door is open. So every command that I was using in the bash language, I can use directly in the terminal for the for the grass. Okay. So, for example, cd ost for SAM grass database, I'm entering directly inside my grass database with what? With bash. Okay. So something to pay attention over here, I will have my Europe, my folder. Okay. And inside my Europe, I will have what? I will have my, now you should know, my map set, psm stat permanent. Okay. And inside the permanent, what I will have? I will have all the structure that I showed you before. So you will have, if you list it in this way, ls minus l, you have vertical information. You have cell, fcell, where you have all the information about your raster file, in this case, raster file, okay? So as I mentioned before, usually you don't go below permanent, you stop in permanent. But this is something that you should know a bit more in advance, that your file are stored over here, that you can do over there something, okay? So in this way, you can start the GUI, but as I mentioned, I will not start if not it's slowing down again. So any kind of operation that you do it under with a bash command is going to be stored in the directory where are you, okay? Grass database. Zoom in a bit more for you guys. Okay, so in this case, every time that I do a command, a bash command, so if I do echo or I do ls, for example, I'm listing directory, okay, that are under my bash directory, okay? So if I do a sequence of file from a sequence of number from 1 to 3, okay, very small, I'm going to list this file. I can save this file to a text, so sequence.txt, and I can, so my file now, my sequence is going to be over here, okay? So in this case, I'm just saying, and just to show you that you have the bash functionality and your output is going to be directly under your grass database. Rather, if I do any kind of like R buffer, okay, that I do any kind of raster or vector analysis, grass analysis, your file, they are going to be saved in Europe. Okay, so be careful about this one. Be careful about this one, okay? There was a question. Can you set database location map just from the command line? I would say yes. You can do it. You can do it directly to enter. Okay. In order to create a grass database and location and map set directly from a command line from a scratch, we will see in the second section. Okay, we will see a second section. And how to change the location, this is where we are going slowly in that line. So these are the command that I mentioned, that they start with each single letter. And you can have the manual of any command r.buffer also in the terminal by writing man and then rinfo, for example, or rbuffer. And this is pretty the same that is in the graphical user interface, and is also the same that you will find online in internet. Okay, so whenever you are here, remember to press Q to enter. Okay, so this is again, the man is not, in this case, man is not a grass command, is a command, a general command from the help of bash command. Okay, so in the same way that to see where you are from the bash from the bash system, from the bash language, you can do print working directory, okay? Each one of these commands is an acronym. So try to link the acronyms with the meaning, the acronym with the meaning of the, in this case, print working directory is going to tell me that I am inside home Giuseppe. So you will have home user OST for SAM GRASS database. Okay, so rather, if you want to see where are you under the GRASS environment, you have to do g.gis environment. Okay. Okay, so this is nothing else that printing your GRASS environment. Okay, so you can see immediately that you are under location, the GIS database, and your permanent. Okay, so as you can see, is perfectly the same of the line that I enter over here. That's why I was entered with the command line directly in this line. But the GIS.gis environment is something that has to be in your fingertips in order to be able to enter it directly. Okay. So this is extremely important to locate yourself, both of them, from a bash perspective and from a GRASS perspective. Okay. So let's see. So let's scrolling down a bit. So this is the concept that I just explained it. Okay, so so this is also the concept that I mentioned about where are you from a bash perspective and GRASS perspective. So always pay attention about these two information: bash location, bash. No, let's call it bash directory, and this one we call it GRASS location. Okay. Now, there was a question how I can shift between location and map set. So the command g map set is helping you always, is helping you to list the map set that are available, okay? And then is also helping you to enter in one particular map set, okay? So he tell you that a little warning concerning the bash history. The bash history is nothing else, all the command that you have done in that before that you have done in that context. So now at this point, if I do again g.gis environment, you can see that has been switched. I'm not anymore in permanent, but in map set. Okay. So these allow you to really understanding that you can migrate inside to the same location. You can migrate and shift the map set as you want. Okay. It's quite rare that you, due to that in the location, you have all the data under the same projection. It's quite rare that you really want to change location and be in GRASS. So most of the time you exit from GRASS and you enter in another location. So it's easier to do in this way, okay? So you never, also because the location, you can have different data set, in the location has to have the same projection. So in another location, you have other projection, so you don't really mix up files with different projections. So it's very rare. There are also a way to change location, but in the end, I never use it. I get out and enter directly. I give the full path again, okay? So let's see how I can list my file. So if I do g.list rust, okay, -p, give you the list of file, okay? So as you can see, I can list file in my, I can list file inside my permanent. So all the file that I will be in my permanent and also in PSM, okay? Now, what does it mean? And now I enter in PSM, I was here in PSM. So now I have to be careful that everything, I can read file from anywhere. So I can read this file. This is a raster file, the one that we opened before that was black. I can read this file from permanent, but whatever I'm going to create is going to be inside PSM because I am in PSM. So that's why, that was important to understand the structure. I can read the file from the different, location, for the different map set, but I can only write in my current map set. So always have in your finger this command, okay, where I am, where I'm going to write, okay? The same is pretty the same for the g.list minus vect minus p is the one that you can list file in vector. In this case, I don't have any vector in permanent, I have only in psem. Okay, so now, for example, we can understand how you can use the file and read the file from another map set. So as I mentioned before, just repeating that I am in psem, so I can read files that are from another map set. So for example, if I want to I think this one. Perfect. So if I want, there is another map set, another file in psem stat that is called fnmpcproc. So I'm going to copy from this map set, this file, and paste it inside my new map set. Okay. So now if you list it, glist rust minus p. Now, if you list it, you can see that over here you have your new file fmpc_crop. Okay, so this is really important because this allow you to read the data from another map set. So be careful about this concept. Okay, so now you are writing, you are inside to this one. So let's see if I can write perfect the same. I want to write to permanent. Sorry. Permanent. So let's see if I can copy from psem start and write into permanent. Okay. Yes. So it give you immediately. Be careful that these underscore, they are not really visible. So it's not a space over here. Eh? Pay attention that this underscore, I don't know, is the last line of my, so if I do like this, pay attention that are not space, but just underscore. So he tell you that I cannot write in it. Actually, he tell me is an illegal file name, okay? Because I cannot write to another map set, okay? So now, for example, if I want to, and the same, if I want to remove a file, let's see if I can remove a file in another map set. If I want to do gmap set rust name and remove to another map set, so I'm trying to remove a file from another map set, is going to tell you you cannot remove file in your maps in that map set because you are not in. So the only way I can only remove a file that is inside to my map set, okay? In that case, you don't need to specify because you are inside psem. So in this case, you can specify without problem. You can specify without problem the map set, and you can remove that data. Okay, now if I do the glist rust, you can see that you have all the list of your raster file, and you have the new one that is gone because I was just remove it. Again, over here, if you are in this case, press Q and you exit. I always prefer to do the -P option because it's printing in a better format, and is also giving me where they are located. Okay, so this is quite important to understand. And they always list first the one that you are in, and then the one in permanent. So try always to have also in mind this g.list rust -p to enter understanding where are you. So this is the concept that I mentioned before. You cannot delete from another map set. Okay, so this is just to explain to you how you can migrate, again, how you can migrate with the with the map set, how you can migrate G map set. How you can migrate from one to the other one. So if I am in G map set PSM, okay, you tell me that you are already there. So if you are doing impermanent, you can enter inside permanent, okay? So now if you do again g.gis environment, you can understand that you are inside that map set. Okay, so this is something that you can keep playing by changing the map set and by changing the map set and creating file and so on. So and again, every time that you are creating a file, you are creating only in your map set. So for example, if I want to also read more information about one specific file, so if I list the raster now, I have this one that is my main file that I'm going to use it. So if I want more information about this file, I can do the r.info because it's a raster file. And over here is giving to me, this is the black file that we opened before, is giving to me the information that also, for example, GDAL.info was giving to me the same information, was giving to me that is his data type. So in this case, is an integer. So they don't use it. They have two data type, cell, actually three data types, cell, F cell, and D cell. Okay. So the cell are the integer, and the F cell and D cell are the two other floating point. So over here, you can see the dimension of the file, so 5,000 by 5,000, the extension, okay, and also the minimum maximum, okay. So all this information they are giving to you, and something very cool also that is tell you where the data come from, which is the last command that has been producing this data. So for example, this one has been using to import directly this data, okay, and this one, pay attention, is it was now is not the machine. But it was an ArcInfo file. So you can read directly raster ArcInfo file directly, the typical ADF extension, you can read directly inside to the machine, to the command. So, and so on. So you can do, for example, the typical r.mapcalc for doing calculation. So for example, if I use my FNMPC, my file, I can do my FNMPC. Again, this is here, I put an underscore, it's a bit awkward, that is not reading. So you can see immediately, I create a new file. I say, for example, my FNMPC times 100, the time 10. Okay, so I just multiply. So here, the r.mapcalc allow you to, you have to put the double quotation. So I'm creating a new file now. So as you can see, now it's running. It's quite a big file. So it was 5,000 by 5,000. So it's not very small. So the computation will take a bit of time. But it's creating now a new file. Where is creating this new file? Inside the map set where I am. So inside the permanent. Okay. Usually something that you don't really work in the permanent. So it's better to work in the other map set and having in the permanent just the file that you want. Okay, but let's suppose that this is a really important file that you have to read from everywhere in the different map set. So then now you will have directly your new file inside your permanent. Okay, so now that you have your file multiplied by 10 ready to use it, then you can shift the different map set, and now you can see from everywhere. Okay, so this is something that you can always play to create. And And now is the time to build up your GIS computation flowchart by nesting all the different commands, okay? So this is something that you can achieving later on by building the different command and building your scripting procedure. Okay, something, let's go to another step that I didn't mention, but is extremely important to understand. So is the region setting. So the region setting is something extremely important to understand and to use it for mainly two reasons, because it can speed a lot of your computation or at least your testing during the computation, your testing phase, and can be also extremely important for high performance computing, for multi-core computation, and we will see how. So let's see what is in particular this region. So the G region, if you print G region minus P, you are nothing else than printing the bounding of your computational analysis, okay? So in particular, if you open, maybe I can only open, let's see, if I open again my GUI UX Python, maybe I can only do it. And so people in the virtual machine, they can don't do it and just see my screen, because if not, we will have many opening. Should not be any problem, but it's just a time of returning. You get all these warning, but don't worry, they are just warning, they are not mistake. So if you open the file of before, the FNMPC, so you open the raster file, okay, so you open the raster file, should come, okay, FNPC, you do apply, and you do okay. Okay, so over here in your screen, you can also select, let's see if it's open in this menu. Yeah, show computational extent, okay? So whenever you show the computational extent, over here you can see this blue line that is nothing else than your computational region. So what does it mean? In this case, the computational region has been set to the same. This is the default. Whenever you enter in GRASS, you are importing a new data, you are creating location and map set with a new data, your computational extent is going to be the same size of your image, of your input data, okay? But later on, this computational window, you can change it as you want, okay? So now if we go back to the, you print, for example, that you want to concentrate your attention in Scandinavia, and you print again this value, you can see that now your computational region is linked to the, is designed with the north and south and east. So if you go back to your user interface and you do a refresh, let's see if it's working, you can see that now your computational region is linked to Scandinavia. So what does it mean, the computational region? Is that this is something that you set up, and all your computation after that you set the computational region for Scandinavia will be only computed for the Scandinavia region, okay? So the same operation that I was doing before, for example, we can do it again, r.mapcalc. I do the overwrite, -O. So now you can see that it is even faster than before. Why? Because my computation has been done exclusively for the region, for that region. So if I open now, my FNPC time 10, coming, you can see that that is computed only for Scandinavia. Okay, so these are quite important aspects. Why? Because during your testing phase, you can, this testing phase, I mean, during your scripting procedure that you are testing, you are building up your script, you can set up a region that is very small. You can see that your speed for the computation is much smaller. And now you can see that my computation, my new file, FNMPC time 10, is only available, is only computed for Scandinavia. So you can really concentrate your attention in making the code, in writing the code without waiting a long time for this execution, okay? So in the beginning of your code, you just set up your region very small. You do all your testing, you see if it's going fine for that computation. And then whenever you are ready for the batch processing, you enlarge your computational region with a flag -d, is bringing back to the full data set, and then you run the computation, and that computation can be slower. You don't need time to process your data and waiting there for processing the data. So this is quite appealing for this aspect. Another aspect that you can set for the computational region is also the resolution, okay? You can change the resolution that, for example, I have over here. You can reset your computational region. So let's suppose that I do again, but rather than 1 kilometer, I do 10 kilometers. So I can reset. Now you can see that I can recompute my 10. Now you can see that it is even faster because it's computing something very cool about GRASS, that you can just make again a refreshment of your image, and you will see that now your image is going to be more fuzzy because you are computing everything. It's coming, you can see just barely. So let me increase a bit more. So you can see now that is fuzzy, okay? So yes, so in this way you are not only changing the computational region in terms of extent, but also in terms of resolution. This is in terms of resolution. Some people, they were asking me, OpenEV can also visualize GRASS raster from OpenEV can also visualize GRASS dataset. I never tried, and I don't use so much because, as I mentioned, probably not, but I never tried. So it's something that you need. If you are creating GRASS database, means that you are already in GRASS, you know. So then if you really want to check with the graphical user interface from GRASS, okay? So, and if you finish your GRASS computation, as I mentioned before, I always pull out my TIFF, okay? And then I can open the TIFF in OpenEV. It's something that you can test, but for sure, you have to go inside to all the directory where you have your, probably the cell value can be open under the F-cell or cell folder. You can have the file of your GRASS raster that you can open without problem. So I don't really use it, but you can try, okay? Maybe you can let me know if it works or not. So this is extremely important for this aspect during during your scripting procedure, setting up a region that is small, and it is also with wide pixel. In this case, the resolution is done an internal resampling based on nearest neighbor. So it's not the best way to resampling an image. I don't want to say that is the best way to resampling an image. I just want to say that it's important to do this kind of manipulation for setting up the time for making the analysis, okay? So another important aspect that, and this is a bit really more advanced, that you can setting up different G region, one for, and you can divide again your raster file in 2 tiles. So you can have left, upper left, low left, and so on, the 4 tiles, and you can do each single region can be sent to a CPU, okay? So a different CPU. So in the same GRASS environment, you can have 4 CPU that are working, each one for each single region. This is extremely complicated to do it, but is the way to go in the multi-core processing under high performance computing. There are also other ways to do it, that for each single tiles of these, you create a completely new location and map set. So this is the way that I use it more, and there are examples how to do it in the high performance computing, and we will address it also tomorrow with some little example. So even we will do it under GDAL and under GRASS. So I will try also to, now it's ready for GDAL, I will try to update with a few lines also for GRASS. So this is something that you can work in that context. So this is the computational region that is extremely important for this aspect. And we saw how to open, okay? We saw how to open. And we say how to open. Okay, so so let me close this one. Okay, leave it open just in case. Another question from Basura was asking me, can I use PK tools in GDAL? Okay, so GDAL and PK tools. So if you just press GDAL in the tab, you can see that you have all the command. So you can do GDAL info for a specific file. Okay, no problem. You can have even GDAL info for a specific file of a GRASS file. We can even try. I don't use so much, but we can try to say Europe. I am inside database. GDAL info. Europe. Permanent. And then cell. Let's see if we have file inside here. No. So over here, I'm trying to point to the, I think you have to, I don't use so much this function, but you have to point to where are located the header, and then you can point the file, and now you can do the GDAL info. So as you can probably, yes, it's not recognized as a support. I think you have to allow you have to allow GDAL info to read raster file. Anyway, this is in the context of if you are inside GRASS, all the functionality of GDAL has, you have it also inside GRASS. So why, for example, for the GDAL info that you have, why don't use r.info, okay? So that you have perfect the same without, so usually it's possible to use PK tools and also GDAL, but you don't really do it. If you are inside GRASS, all the functionality of PK tools and GDAL, you are there. So you just look into the manual and try to find which is the GRASS command that allow you to do the computation. So that one, another question was, can we detect pixel change of some location using tools? I mean, I think it is mentioned that by here you can click in each single pixel, and you can query the result of that specific specific pixel. So over here you can get the value, and every time that you click, you can also retrieve it. Or this is the manual user interface. Was like yesterday we were we were checking for GDAL allocation info for retrieving a point file. In GRASS, there is this r.what that you can give coordinates or even a vector file, and he will retrieve information about that pixel. And of course, if you have 2-3 files, you can give, I think you can give more than one file. You can go into the help and see that you can give more than one file. Yes, so if you give more than one file, for example, you do some change analysis and you want to see if that pixel has been changed, you can give before the change, after the change, and you can give the coordinates of that specific point, and you can retrieve the changes. So I can even get in fast in this way. I can get that number if I can copy to the clipboard, and you can get this coordinate are what, and you can build up in this way is really the typical situation that you build up your scripting procedure. Okay, by looking the manual and checking how to, so you do map FNMPC, FNPC, FNPC, and you can get your value in this case is 0, okay? But you can even give, indeed was also 0 over here, you can also give 2 files over here, so you can do, for example, the FNPC and the one that we built before, it was 10_10. So in this case, it's going to give 2 numbers. Of course, we multiply the 0 by 10, so it's going to be 0 in both cases. So you can get the pixel afterward. And in this way, it's just a matter of searching the command that is doing whatever you want to do it. Again, all the GIS analysis that you can think about changing resolution, buffering, watershed analysis, cost path analysis for track analysis for animal tracking and so on is very open to, is very fast in this kind of computation. So you can search, there's plenty of information. And in this context, I can really point to you, if you just Google it, GRASS add-on. So you can arrive to this page where you can list, where they list all the different you can list the different, yes, here. You can list all the different raster and vector analysis. So the general one, but the one that I always use it are the one especially in image processing, okay, in image processing, but also in the raster environment is the one that I insist. And you can use the function g.extend to import directly and install a new file, so for people that are working in hydrological modeling, for example, a few years ago I was developing this watershed GIS extension, add-on extension. That one actually I encourage you to search for it. Because it's a combination of Bash language watershed, so not this one. Yeah, RStream watershed and RStream variable and RStream watershed. So these are, I really suggest you to look the code because he use a lot of changing of G region and multi-core computation for a massive computation in this context. So that one is a real example how to combine all this information for a multi-core, so changing the region, changing the map set, using sending each single region to a different core of the computer. So it's a quite complex way of to use. The way to use it is very easy. You can follow the manual, but it's more complex how to I build up the scripting procedure for this multi-core operation. So if somebody want to go there, that's why it's good to have this open source code that you can go and check. So going back to the exercise, more or less, and nothing else that over here, play a bit with the resolution, like I mentioned before, by changing resolution, by changing the resolution in the G region setting, and also by changing the dimensions. And you can see how the different files that I was creating by changing the resolution. So it's nothing else that what I saw before. For importing new data set, we will see inside to these, you can use the R-in-GDAL. That's why that the R-in-GDAL is the command, is the GDAL wrapper inside GRASS to import the command. So actually the one that I tried before, if you insist more and you search for the right, the GDAL info, is a GDAL info able to read the raster file? Yes, because this one is also allowed, the RGDAL, so you need really to do it the right path, enter in the right directory in order to be able to read that file. So, so the RGDAL allow you to import in some data. So this is very appealing in this context. So this is so feel free to keep testing also other command inside for the people that are inside the virtual machine. But something that I want to really point to you is how you build up completely from scratch your data set. Okay, so if you go back to the main page, you can go directly into the material number 2. Okay, so maybe Christine, you can paste again the link of material number 2. So be sure that you exit completely from GRASS, okay, and that all your windows are closed. Sometimes if you close one window, you don't exit from GRASS. So be sure that you are listing over there. So now we migrate to the material number 2. Okay, so if you click in material number 2, you arrive to this page. No, material number 2. No, is this one.
Giuseppe, I don't know which one material number 2 is.
Perfect. I just posted.
Oh.
Number 2. So I can go and follow this new exercise that is allow you to create a completely new data set. Okay. So let's go and start from scratch using a data set that already exists. And we will see when I mention to you, you have to be sure that your data set has the right information. We will see what to do and what not to do with the data set and checking. So in this case, for example, I'm just creating a complete new GRASS database. So my GRASS database at this point is completely empty. Okay, there is nothing, it's a completely empty directory. So I have one file that I'm going to use it as a test, and that is my input file. So if I paste, okay, so I can see that I can open in this case with the OpenEV, okay, I can see that it's just a very broad resolution file. Perfect. Okay, so it's a 0.25 temperature file for Europe, 0.25 degree. So this file, you can get the GDAL info. You can see that has extension, but do not have any information about the projection. So be careful. This is the mistake that you do not have to do it. You don't have to use it a file without projection in GRASS. If not, it's getting extremely complicated. Okay, so be sure that you have the file with the projection information, And for example, you can use GDAL warp to assign, in this case, the projection information. In this case, I know that that file is in lat long at global level. So I can use the 4326 to create a completely new file that in my case, I'm going to call it input proj. Okay, so my file now, the input proj, I call it input proj, is going to have a complete projection information. Now I know that is belong to the 4326 file, so the computer knows that, okay, is in degree in which kind of projection is inside to the system, okay? So at this point that you have a completely new data set, and a data set that you want to create the structure of GRASS, you can use this command that tell you, start GRASS in the text mode, create using this one as a reference data, create a new location inside to this GRASS database new. Okay, so now if you run this, you can see that I'm creating the location. This location is completely empty now. There is nothing. So it's, but has been built all the information. So if you migrate inside here, you can see that I have my new location. Inside new location, I have my permanent that I told you that is creating it automatically every time that I do the creation, the automatic creation. Inside permanent, I have only the information about the region, the projection system, and so on. There is nothing yet about the data. Now I can use RNGDAL to import the data. So RNGDAL is bringing the TIFF and is creating all the folder that I was mentioned before. So now you can see that all the file has been imported. And if you list, now you can see that it has been populated with more folder information. Okay, so this is extremely important in the case you want to automatize the scripting procedure and you want to build GRASS location and map set directly in your system. So pay attention that the same procedure you can do it if you have many files that you want to import. And so for this one, I'm not going to run it, just for an example that you can import several files. Be careful, several files that have the same projection information. So always pay attention to point files that have been under the same projection parameters. So always GDAL info, check if all the file have projection information and they are the same, then you can import all of them. So if you organize in very structural way, then it's becoming really easier to work. If your file are completely messed up with the projection, then it's going to be really difficult to dealing with the projection inside GRASS. So do it before. Okay, so this is how I usually perform the operation. There is also another way that you can do it. Actually, is a bit more, is newer because it's been developed like two years ago. So if you exit now from GRASS, you can perform the same operation by this syntax. So be sure that you are in the same GRASS database. You remove the one that we were just creating. Okay. So now at this point, look, I'm always using this file. So now at this point, I can run my full command that is going to create a location. Okay, it's going to create a location. So now my location is going to be created. Now my location is going to be created. I think so. And now I can run. Okay. So every time, this allows you to run GRASS command be outside GRASS. And so for doing this, every time that you run the GRASS command, you have to specify again where you want to run, in which new location permanently. So now, if, for example, if I run the information of this file with the rinfo, I can see that my file has been creating, and I can keep working line by line over here below to build up all your scripting procedure. So this is the typical way that I use it. For building up my my GRASS location and map set on the fly, I say, and keeping working that direction. The E stay for exit. So you create a location and you exit. And then every time you re-enter in GRASS, you perform that command. Enter in GRASS and perform another command, okay? And so on. Somebody else was asking me, are the different files need to have files, geographical file, the different extension, no extension in terms of extent? No, they can have a different extent, but be careful because your G region is setting in automatic at this point. So pay attention. The G region, whenever you set for the first time, the G region, you enter, complete a new parameter, a new file, a small file, let's say, is setting the G region for Euro, like we say. Now, if you're importing a file that is going to be larger, the file is going to be imported all. But every time that you are going to do the computation is going to be only for Europe. So be careful. Yes, you can import in different extent, but every time you have to readjust your G region like I mentioned before. So these are all aspects that you keep, if you know the structure, in particular, again, map set and location, other way around, sorry, location and map set, GRASS database location and map set, and the G region, how to play with the G region, then you can understand all these parameters. In the context of the G region, there is one file important inside the permanent, that is the wind file. This wind file stays for window, store the information about your map set extent and the G region and the maps extent. So as you can see now, this one has been set. So if we get the GDAL info of my file that I was checking before, so of my input proj of this file, if you get the information of this file and that window, it's going to be perfect the same. Okay, so it's going to be perfect the same. So you can compare 34, you can have over here also the 34. Okay, these are expressed in digit and in degree. So they are different, but if you make it a conversion, they are perfect the same. Okay, so this is something that you can play in that context, in this context. So these are the main concept that I was trying to cover today about the structure of GRASS. Okay, so this is really is last web seminar in terms of presenting each single language. Okay, so as I mentioned several times, it's good to know several one, and this combination of language and language integration is becoming quite complex. So try to strengthen your especially if you are beginners, trying to strengthen the knowledge in each single one, and then you will see a moment that you can say, wait a moment, this one I can integrate now with this other language. So these allow you a really well integration in powerful analysis capability for this content. So we can have a bit of time to addressing more questions. I was trying to look also from some questions. So some have been replied through my talk. So please tell me or repost again if you have more additional question or if I skip one at the beginning. So and then we can try to answer. We can have even a bit more time after 11. So always try to follow the material. There are plenty of material also in the GRASS. If you go into the GRASS main page, there is the North Carolina, they call it North Carolina sample data that you can always referring to for making some example and so on. So also that one, you can find a lot of this material online. Let me see some question. Yes, Christine is also asking to refill a questionnaire, a survey that is helping us to achieve other web seminar in this contest, and they are anonymous, so feel free to express your feeling and your knowledge that you acquire. Good question about is the wind file editable? The wind file is a very good question. It's a text file. So in theory, not in theory, in practice, you can open with an Emacs or with an editor. Okay, so in this case, I can go here and change it manually. Or even better, you can replicate window 1, window 2, window 3, and use this one every time that you want to set up a new region and create your tiles. So in reality, you can even building up, you do a for loop that is changing this dimension, okay? And you can create tiles in this way. Very good question. So you can create, usually I have, for example, I have already my full grid text file in the globe, dividing different tile system, I call it. So I can have the 5 by 5 degree tiles, the 10 by 10 degree tiles, 20 by 20, and so on until full globe, one tile. So in that case, I can use this text file with my extent to fill it up and create many of these window files with bash syntax and text manipulation. And then every time that you enter in GRASS, you can point to Windows 1 for tile 1, Windows 2 for tile 2, and so on. So it's something that you can play around with this one. Anyway, good question that you already think behind the talk that I was giving. Another question: how to integrate Bash and GRASS. So for example, let me enter again. Oh, I can enter in there. Yeah, so for example, let's do the rinfo of this file. Perfect. So now I'm outside, so you can see that I'm outside to GRASS, okay? There is, for example, I think the our report unit. Let's see if I can guess the unit equals C. Okay, it's giving me the units is plural. Okay, so for example, input report, I have to say map. Okay, so for example, yesterday we were seeing pkstat with the option and bin that was able to create histogram for TIFF file. There is the same kind of function with the R report unit C that is giving to me information about for each bin how many pixels I have. So in this case, for example, the question was how we can integrate the two languages together, Bash and GRASS. These are already in the same environment. So over here, I can, for example, call a specific, and like say, for example, grep a specific number. I want to only the bin, only the the number of pixels in this line. So it's giving to me only this one. And if you continue, for example, I want to, you can also open, you can use Oak to say, okay, print me, in this case, only the number of field. So the last line, sorry, the last column, it is going to be the number 1. Okay, and then you can get even rid of this pipe with another Oak syntax and so on, seed. So this is the powerful of the, everything that you print in the screen is going to be a text file that you can manipulate directly. So even, for example, here you are running a bash command, sorry, a GRASS command, then you are manipulating your output with a bash command, in particular with grep, with Oak. So these are really advanced tools, but that allow you to really express all your skills in computation and achieve a really high level of scientific capability, yes. So how to extract a statistic? So the same file that you were using, perfect. So the same file that you are using over here, the same file that you are using, you can save it to a file. Okay, so this one is going to be my hist.txt, and this is just a txt, so you can import it directly in R. Okay, I will not import it in Excel. If not, you are back to the problem of not be able to integrate the command complexity. These are, again, for example, I can point to you in this language integration page. There are a lot of these example how to integrate Bash with R, or PK tools and OFT tools. Somebody were asking me about how to integrate the GRASS in R. This is an example over here. And in this case, that you create your text file. Okay, so your text file, of course, is going to be full of these this part that you don't need it, but you can use it. If it's not too big, you can import directly in R without problem, and you can use R to clean it. But if it start to become big, you can use directly Oak to eliminate these. So you can say print $2, the column number 2, and it's going to print just the number, and then you can do print the last one, and then you can keep working and remove it also this from that is still there and so on. So there are different techniques that you can use it. You can set up the field separator, FS, I think it is, and you can say directly, I think you need, I think yes. So you can play a bit in this context and play anyway, always, yeah, this is, even if I don't remember the command after a few times that you try, you can figure out how to do it. In this case, for example, now you have completely clean. You can print also the last column, number of field, that you have the number. Actually, it's not the last field, but it was, I think, -1. So now you have also the number, okay? So now you need to keep working in removing this line because you don't need it. So you can say if my row is bigger than 20, start, and then you will have another few way to remove this point in the end. So and then in the end, you can enter in R just with the histogram that you need, okay? Without additional not needed material, not needed file. Of course, now this histogram is just maybe 200 line, I don't know, maybe 200 lines. So R will deal it without any problem, even 200 line. But if this one is start on 2 billion line, removing this one, it will be great for R to have already a clean data set and not to deal with afterward in R. So this is how you combine different language in this context. So we have another, we can wait a few minutes more for other questions, and we can tomorrow we are going to follow the instruction how to perform multi-core operation in the high performance computing. Is going to be, there is not going to be any hands-on because I'm performing in the Yale cluster, but we are going to use, the Yale cluster is running a queuing system under SLARM. SLARM is the queuing system that are used in many clusters nowadays. Probably is the most used one, is the newest. Is not the only one, but is the newest. So everybody, I think, adapted to this SLARM queuing system. So I set up my scripting procedure for the SLARM. Anyway, if your cluster has another system of queuing system, you just need to change a few the syntax. What is important is here real the syntax, yes, that you are using. And we are going to use this material that I set up last year for a similar course. I will try also to integrate with a few tips for GRASS that at the moment are not there. Anyway, so this is for today, for day-to-day talk, yeah. Feel free to post or mail me directly. Christine, you can write my email, giuseppe.amatulli@yale.edu. Another question. So if you want to work in a file with a combination of GDAL and GRASS, I need to create a GRASS environment, run the wanted command, and then export a TIFF, and then close the GRASS environment. Yes, perfect. You get the point. So I do my operation in GDAL. I enter in GRASS with this line, GRASS exec. I do my operation GRASS. I pull out the TIFF, and then eventually I can access and opening the TIFF. So perfect, the same point that we were saw over here. So in other words, Tamir is asking me, so this will be my flow. I do some operation in GDAL, I do with some other operation PK tools, I cropping, whatever I want to do it. Then I enter in GRASS, I create my location in GRASS, I do my analysis, then I pull out with R. There is also the same function like in GDAL, there is r.out GDAL. So I pull out in the same way r.out GDAL, and then I have my TIFF ready for another analysis or just for visualization in OpenEV. Okay, so this is quite appealing way of working. Yes. Another question from Bernardo. For our report, for example, there is the output option in fact possible. Perfect. Yes. So this is something. For example, always read the manuals, because the operation that I did for cleaning, maybe there is already a flag that, like Bernardo was reporting, that allow you to remove all this line in the beginning. So always try to see in the GRASS manual what you can use it to have a better clean output. But for example, there was not, I think, I don't remember, there was a way to get rid of the column separation. Anyway, if it is not, then you can find another bash tools to combine this way. So it's a combination of different trial and so on. Okay, cool. So we will resume tomorrow at the same time. We have the Spanish section. We have the Spanish section running in 2 hours. So I will address the Spanish one in 2 hours. So if someone, or if you have some colleague in the spoken country, please feel free to refer to to the same material and the same web page that we were using, the DocuWiki, because we are going to have the same section in 2 hours in Spanish. And we talk tomorrow at the same time, 9 o'clock, New York time. Yes. So thank you very much for your attention, and remember to filling out the questionnaire if you have additional question, or if you want to enter in the mailing list of the spatial ecology. We send very few emails a year, so you are not getting any spam. We send like maybe 7-8 emails a year about, so you can find the link over here, register yourself, and you will get this information available through different courses in the application that we run. Okay, Christine, I think we can resume.